Ever feel like you're drowning in information? You just want the core story, right? The stuff that matters.
Absolutely.
Well, today we're doing just that, a deep dive into the history of AI. We've got accounts, inventions,
The
publications,
real deal.
the foundation of how it all began, our mission. To give you, the listener, a clear understanding of AI's origins, those aha moments, and the people who made it happen.
Right. We've gone through these sources and traced this incredible journey from the earliest attempts at automation all the way to the models we have now. You'll see how it all connects, often in surprising ways.
So let's go way back. I mean, way before digital, anything digital. People were dreaming of automation centuries ago.
Oh, yeah.
Take Hero of Alexandria, 1st century AD, mechanical figures. He even made a miniature theater that was programmable.
Right.
Programmable in the 1st century. What's the takeaway there?
Well, the amazing thing is, even back then, with simple mechanics, gears,
Yeah.
levers, they had this idea of setting up a sequence of actions to run automatically.
Yeah.
That's programming at its core, isn't it?
Yeah.
Instructions for a task without needing a human there all the time. An early seed of a core AI concept.
And then jump ahead, like over 1,000 years to 1206. Al-Jazari built this water-powered humanoid orchestra.
Wow.
Mechanical musicians playing different tunes, controlled by pegs and cams. Sounds like something out of legend.
It does, but it shows this age-old desire to create machines that mimic what humans can do.
Right.
And those pegs and cams, another early form of programming, encoding instructions in a physical form that the machine can read. It's like a medieval version of telling a machine what to do.
Then fast forward to the Jacquard loom, early 1800s. This one really got me. Punched cards controlling complex weaving patterns.
Amazing.
How did something so simple become so important?
The key is those holes in the cards. They represented information. Presence or absence. Hole or no hole. That dictated the threads. A real physical demonstration of binary information, instructing a machine. It's no exaggeration to say this idea, those cards, they deeply inspired people like Charles Babbage.
Babbage, yeah, the 1830s, his analytical engine. Never actually built, but the plans? Incredible. A mill, the central processor, a store for memory.
Right.
And programmable with punched cards. Why is he considered the father of the computer if it never even existed?
Because his design had everything a computer needs. The mill, the CPU, the store, the memory, and most importantly, the ability to be programmed. Different instructions, different tasks. The blueprint was there.
Then we have Ada Lovelace, 1843. Working with Babbage, she wrote an algorithm for that engine.
For what?
To calculate Bernoulli numbers. That's considered the very first computer program. But she saw something more, didn't she?
Oh, absolutely. Lovelace realized the engine wasn't just about numbers.
Yeah.
She saw it could manipulate symbols, create things like music even, amazingly predicting what would become crucial for AI symbolic processing. Machines working with ideas, not just quantities.
Let's jump ahead now. Early 20th century. 1912, Alan Turing is born. Can't talk about AI without him. Mathematician, logician. He laid the groundwork.
It did. His concept of the universal Turing machine, 1936, groundbreaking. It's essentially defined what a computer could do. And his work during the war, breaking codes, showed the practical power of computation. The foundations for computer science, for AI, are right there.
But then, in 1914, Leonardo Torres y Quevedo, he builds this chess automaton, El Ajedrecista. Not just theory, it actually played a simple endgame on its own, the first computer game. He was even writing about machines that could think.
That's right. El Ajedrecista showed that a machine could perform logic to achieve a goal. And his ratings. Early thoughts on what we now call AI, machines showing cognitive abilities.
It's interesting, both John McCarthy and Marvin Minsky were born in 1927, setting the stage for their huge impact later on.
Absolutely. Their births precede their incredible contributions to the field, defining, shaping AI in the mid-20th century.
1943, a big year. McCulloch and Pitts propose a mathematical model of artificial neurons. How did that connect the biological brain to the idea of AI?
They created a simplified mathematical version of how neurons might work, showing that these artificial neurons could, in theory, do logical operations when connected together in networks.
Oh, okay.
A foundational step for the connectionist approach, building intelligence by mimicking the brain's structure.
Interesting.
Also in 43, Wiener and his colleagues coined the term cybernetics,
Cybernetics.
the study of control and communication in animals and machines, a focus on feedback loops. That had a big influence on early robotics and AI.
And in the mid-40s, 1945, Vannevar Bush writes, "As we may think." He envisions machines that would augment human intellect, particularly his Memex device. So forward-thinking.
It was. Not AI in the way we think of it now, but that MEMEX concept, storing and retrieving information through interconnected links, it foreshadowed personal computers, the internet, technology helping our thinking.
Yeah.
A powerful vision for early AI researchers.
Then, 1950. Alan Turing again. His paper, Computing Machinery and Intelligence. He introduces the famous Turing test.
The imitation game.
Can a machine fool a human into thinking it's also human?
That paper was a turning point. Turing moved the focus from calculation to behavior. The test became a benchmark for evaluating machine intelligence. And he discussed machine learning, not programming intelligence directly, but teaching machines to learn.
Okay, so we've got the groundwork. Centuries of ideas converging. The 1950s, the birth of AI as a field.
Right. And 1951 was key.
Yeah.
Minsky and Edmonds at MIT built SNARCAR, the Stochastic Neural Analog Reinforcement Calculator. The first machine to use an artificial neural network, a network of interconnected nodes, like the brain, to learn to navigate a maze. This was the connectionist approach in action, building intelligence from the bottom up through learning.
40 artificial neurons. Sounds simple now, but it must have been amazing to see machine learn like that.
It was a very early demonstration, the machine adapting its internal connections based on experience.
Then, 1952, Arthur Samuel at IBM. His checkers program, it didn't just play, it learned from experience.
A huge step towards what we call machine learning now.
Yeah.
His program was a pioneer. It analyzed its past games, adjusted its strategy. It even became better than Samuel himself. And in 1959, he coined the term machine learning, giving computers the ability to learn without being explicitly programmed.
And that leads us to 1956, the Dartmouth Conference, often called the birthplace of AI. What happened there?
The Dartmouth Summer Research Project on Artificial Intelligence. It brought together all the big thinkers, McCarthy, Minsky, Shannon, Rochester. McCarthy coined the term artificial intelligence there. They set out this ambitious goal to understand and replicate all aspects of human intelligence in machines. It really formalized AI as a field.
It wasn't just talk, though. Same year, Newell, Simon, and Shaw developed the logic theorists.
The first real AI program, they say,
Yeah.
to prove mathematical theorems. Amazing. It could prove a good number of theorems from Principia Mathematica. What was new was its use of heuristic search methods, ways to find good solutions efficiently, even if not the absolute best every time. An early demonstration of automated reasoning.
The momentum keeps building. 1957, Newell and Simon, again, the general problem solver, GPS, to create one program that could solve a wide variety of problems.
The idea was domain-independent AI, a system that could apply general problem solving to anything. Puzzles, theorems, you name it. It didn't quite work out practically, but conceptually it was a big step. And then, 1958, John McCarthy creates Lisp at MIT. Why was that so important for AI?
I've read Lisp was the language for AI for decades. Why was that?
Lisp was designed for symbolic processing, manipulating symbols and lists of data. That was crucial for early AI. Working with logic, natural language, it was perfect for exploring complex AI ideas that were changing rapidly.
Can't forget Rosenblatt's perceptron in the late 50s. Early neural network, and it caused quite a stir.
It did. It was a big step. A neural network implemented in both hardware and software. It could classify patterns by adjusting the weights of connections between its artificial neurons.
Interesting.
Now, the early predictions were a bit too much. Some thought it'd lead to machines that could see and understand like humans almost immediately. But it introduced key concepts about learning that would come back in a big way later on.
1959, Samuel's checkers program keeps getting better. Machine learning is becoming more solid. And Oliver Selfridge proposes his pandemonium architecture for pattern recognition. Sounds kind of wild.
It does. Different demons recognizing different features. An early model for how machines might perceive and interpret the world.
So the 50s, a burst of optimism and foundational work. What happened in the 60s and 70s? Did that energy continue?
The 60s and 70s, well, progress, but also a realization that it was really hard to make truly intelligent machines. Mid-60s, Joseph Weissenbaum creates ELIZA, one of the first natural language processing programs.
ELIZA, yeah. It mimicked a Rogerian psychotherapist. Clever, really. Showed the power and maybe limitations of early natural language processing.
Exactly. It could create this illusion of understanding and empathy. But really, it was just following simple rules, demonstrating that computers could engage in what seemed like conversation.
Right.
Then, 1966, Shaky the Robot at SRI. A big achievement, the first mobile robot with AI. Navigation, perception, planning actions. Life magazine called it the first electronic person.
I've seen pictures. This boxy thing on wheels with a camera, it really brought together perception, reasoning, and action in a physical machine.
It did. Shaky could figure out how to push a box to reach a higher platform, combining computer vision, world modeling, and planning.
Mm.
We also see the rise of early expert systems. Dendril, interpreting mass spectrometry data, and the logic-based language Prolog in 1972. Systems aiming to capture human expertise in specific fields.
It sounds like the focus is shifting towards these knowledge-based systems, expert-level performance.
Yes, exactly. But there were setbacks, too. 1969, Minsky and Papert published perceptrons. They proved that single-layer neural networks had limitations. They couldn't even learn simple functions like the XOR logic gate.
And that had a big impact, right? Kind of put a damper on neural network research.
It did. Funding and enthusiasm dropped. Research went more towards symbolic AI. This was a sign of the first AI winter coming, and it hit in the mid-70s. The Lighto report in the UK, very critical of AI progress, led to big funding cuts. Similar things happened in the US.
So, after the excitement of the 50s and 60s, a period of less optimism, less money, what kept researchers going?
Well, important work continued, despite the funding. Cordell Green explored using logic for robotic planning. And in the mid-70s, MYCIN was developed, an expert system for diagnosing blood infections. It showed the potential of capturing human knowledge as rules, expert-level performance, but for a specific area.
So even in the downturn, progress. Then the 80s, a resurgence of interest, especially in those expert systems.
Yes, the expert systems boom. XCon at Digital Equipment Corporation, automating computer order configuration, saved them millions, apparently. We also see specialized computers for running Lisp, the AI language.
So winter to spring, but I read that this boom didn't last either.
Right. The market for those Lisp machines crashed by the late 80s. In the early 80s, Japan started its fifth-generation project. Really ambitious. Advanced AI, parallel computing. It didn't achieve everything, but it did boost AI research globally.
It sounds like a cycle. High hopes, then disappointment, leading to these AI winters.
It was. And even during the boom, some warned that the hype was getting ahead of reality, predicting another downturn. By the late 80s, the Lisp machine crash, the fifth-generation project scaling back, funding cuts, another AI winter begins.
So amidst all this, what about the core advancements, algorithms, theory? Were there breakthroughs happening in the 80s?
Definitely. Research continued. More sophisticated ways to represent knowledge, like frame-based systems, advancements in computer vision, Judea Pearl popularized Bayesian networks for handling uncertainty, and crucially, renewed attention to recurrent neural networks. And the rediscovery of the backpropagation algorithm, a way to train multi-layer neural networks efficiently. That paved the way for the deep learning revolution later.
Amazing how things that were overlooked became so central. The 80s also saw a shift towards using data and statistics in AI.
Yes, a key paper in '88 from IBM, Statistical Machine Translation. Instead of hand-coded rules, they used tons of text data to learn the probabilities of translating between languages.
Interesting.
This data-driven approach really worked, becoming dominant in speech recognition and translation.
And at the end of the decade, 89, Jan LeCun at AT&T Bell Labs shows off a multi-layer convolutional neural network, recognizing handwritten characters. This feels like a turning point for neural networks coming back.
It was. LeCun's work showed that, with enough data and computing power, neural networks could solve real problems.
Yeah.
His convolutional neural network, inspired by the brain's visual cortex, was even used in chuck reading machines, a practical application.
So, the 90s and 2000s. AI starts to feel more present in our lives, even if not robots walking around. The internet explodes, new applications.
Yes. 1997, a big year. IBM's Deep Blue beats Garry Kasparov, the chess champion. A huge win for AI, but it was more about brute force computation.
Right.
Kasparov himself said some of Deep Blue's moves, which seemed creative, were a result of its sheer processing power. It was symbolic AI, but in a very specific domain.
Then things broadened. The internet, intelligent agents, machine learning on massive data sets.
Exactly. Intelligent agents managing spacecraft. Amazon's recommendations suggesting products. Data mining emerges. Robotics keeps advancing. Honda's Asimo in 2000, walking, recognizing gestures.
And around 2000, Yoshua Bengio and others, their work on neural probabilistic language models. How did that change things?
That was crucial. Using neural networks to learn the statistics of language could really improve things like text prediction. It paved the way for the advanced language models we have now. There was also a broader shift towards probabilistic methods, things like hidden Markov models and Bayesian networks, used in all sorts of applications, speech recognition to medical diagnosis.
2001, A Space Odyssey. That HAL 9000, so advanced compared to the real AI at the time.
Right. We weren't close to HAL, but steady progress was being made. Computer vision, planning algorithms for robots, cognitive architectures trying to model thinking.
Then, 2005, the DARPA Grand Challenge. Stanford's self-driving car, Stanley, navigating a desert course.
A landmark achievement. It showed that AI could perceive and control a vehicle in a complex, real-world environment. A boost for autonomous driving.
Yeah.
Then 2006, the start of modern deep learning. Hinton and his colleagues, their new techniques for training deep neural networks, overcoming some of the old limitations.
That, plus the increasing power of computers, especially GPUs, set the stage for the deep learning explosion in the 2010s.
Absolutely. Bigger, more complex networks, tons of data, more computing power, the key ingredients for all the breakthroughs that were coming.
And they came fast. 2011, IBM's Watson wins Jeopardy, a real showcase for natural language processing and knowledge retrieval.
It was. Watson understanding complex language, accessing a massive database of information, answering tough questions.
Same year, Apple launches Siri, voice-activated AI in millions of pockets.
A big moment.
Yeah.
Natural language interaction became mainstream. Siri paved the way for all the other AI assistants. It changed how people interacted with their devices.
2012, the image recognition breakthrough. Google's network recognizing cats. AlexNet wins ImageNet by a mile. A real game changer.
It was. Deep learning, convolutional neural networks specifically, showed they were far better at recognizing objects and images. They learned features automatically from the raw data. No more manual engineering. So many new possibilities for computer vision.
And not just static images. 2013, DeepMind's AI mastering Atari games using deep reinforcement learning.
Deep Q networks, or DQNs. One system learning lots of different tasks just by interacting and getting rewards. Deep learning and reinforcement learning combined, creating agents that learn complex behaviors with very little prior knowledge.
The mid-2010s, generative adversarial networks, GANs, AI generating new data, like images. Exciting, but maybe some concerns, too.
GANs were really new. Two neural networks competing, one making fake data, the other trying to tell real from fake. The result, incredibly realistic synthetic images. Great for things like art, but questions about misuse, too.
And around the same time, Facebook's DeepFace, near-human accuracy in facial recognition.
Deep learning was making rapid progress. Perceptual tasks like facial recognition got much better. Applications everywhere, from security to social media.
2016, AlphaGo beats Lee Sedol, the Go champion. Go is so complex, this felt even bigger than Deep Blue and chess.
It was a landmark. Go has so many more possible moves than chess. AlphaGo, using deep neural networks and reinforcement learning, showed that AI could master strategic thinking, even something that seems intuitive.
Later in the 2010s, that robot Sophia gets citizenship in Saudi Arabia. Robot rights, humanoid robots becoming more visible.
Sophia wasn't human-level intelligence, but it showed the fascination with humanoid robots, the need to think about the ethics of advanced AI. And then, 2017, Google Brain and the Transformer architecture. Attention is all you need. The foundation for the large language model boom.
The transformer seems to be the key. What unlocked these powerful language models?
It is. The attention mechanism, it lets the model weigh the importance of different words when processing language. It's great at capturing long-range dependencies, breakthroughs in translation, generation, understanding. BERT, GPT, they're built on this.
Which brings us to now. Large-scale AI everywhere. 2018 to today, an incredible period.
It has been. 2018, OpenAI's GPT-1, Google's BERT, the start of the large language model revolution, huge amounts of text data, transfer learning, training on general data, then fine-tuning for specific tasks.
And AI is everywhere now, in our homes, online, shaping what we see and do.
Yes, a pervasive technology. Voice assistants, recommendations, personalized everything, even specialized AI, like the companion robot Lovett.
2019, GPT-2, Turing NLG, even better text generation. Concerns about misuse, too.
Those models showed what happens when you scale things up. Huge models, tons of data, but serious ethical questions too. And DeepMind's AlphaStar playing StarCraft 2 at a grandmaster level. Reinforcement learning tackling really hard problems.
2020, AlphaFold solving the protein folding problem. AI making a real difference in scientific discovery.
AlphaFold predicting protein structures from their amino acid sequence, transforming biology and medicine, speeding up drug discovery and basic research. And 2020 also brought GPT-3, even bigger, amazing text generation, few-shot learning.
GPT-3 was everywhere, so versatile it felt like a step towards general AI.
It did. General purpose language, AI, but also discussions about the huge computing power needed and the potential for misuse. Then 2021, DALL, creating images from text descriptions, multimodal AI.
Generating images from text was mind-blowing, and GitHub Copilot, AI helping write code.
DALL was a breakthrough. And then 2022, ChatGPT, conversational AI for everyone.
Yeah, ChatGPT. It took off so fast. Intelligent conversations, accessible to anyone. It started an AI arms race.
ChatGPT showed how far things had come. Advanced AI, easy to use. Everyone wanted in on conversational AI.
And last year, GPT-4, multimodal, human-level performance on tests. Open source models like Lemma 2, making AI research more accessible. More amazing stuff from Google DeepMind and Anthropic.
2023, incredible progress. More powerful models handling different kinds of data, longer sequences of information. The possibilities just keep expanding.
So looking ahead, 2024 and beyond, what are the big trends in AI?
Well, research into even bigger, more efficient models. More sophisticated AI agents doing complex tasks. AI writing code. Integrating large language models with other tools. The big picture. More general-purpose AI, multimodal, learning and reasoning across many tasks. We're getting closer to truly autonomous intelligence.
What a journey. From those early mechanical devices to the AI we have today, the speed of innovation is just stunning.
It is. And all these different inventions and ideas over centuries, they all led to this. We've only just scratched the surface, but hopefully you, the listener, have a better understanding now. How AI has evolved, the key moments, the brilliant minds behind it all.
So one last thought. Given all this, what do you think? What's the most exciting or maybe the most concerning potential of AI in the coming years? Think about the ethics, the societal impact, the personal impact, and if anything we talked about sparked your curiosity, go explore. Thanks for joining us on this deep dive.